Alright, so that being said, or all that being said, we talked a little bit about byte arrays, how they are how byte arrays relate to assembly instructions or just instructions in general. Take a deep breath here. We're diving into some serious shit. Alright. There's no way that we can tell Cheat Engine to search for MOV space tab, whatever you want, ESI plus 000, yada yada yada, E0 EAX. There's no way that we can actually tell Cheat Engine to do that. Or is there? Because as we talked about in the previous videos, what's really going on here is that opcodes and parameters are translated into a series of bits and bytes, and those are fed directly into the processor, and the processor just sort of has some magical way of saying, I know what that means, I know what this means, I know what that means, and bam, boom, pow, profit. How can we search for this instruction? Because we have already demonstrated that, every time we restart the game, our script is going to break. What we want is an agnostic way of searching for some instruction or some instructions so that we never have to sort of find the value and plug it into the script. And again, the way we do that is with AOBscan. And the way that AOBscan works is that you tell AOBscan to search for an array of bytes. And if you haven't figured it out by now, AOBscan is really just a moniker for array of byte scan. It scans for an array of bytes. What array of bytes is it scanning for? It's scanning for this array of bytes that we have been sort of dancing around the whole time. All you got to do is find the instruction, write a little script or whatever, and then you just tell AOBscan, hey, go find this array of bytes, and then done deal. You have a pointer without actually ever having to do a pointer scan, and now you can write all kinds of crazy values to that. Is it really that easy? It is not. And the reason why is, as we will see, we have the bytes here for this instruction. The bytes, or the bit pattern, if you will, of the instruction here is 89, 86, E0, 00, 00, 00. It's exactly what we have here. We have the hex box checked because it is in fact hex. We have array of bytes. Let's ask Cheat Engine, go find this array of bytes and see what we get. How many values do you get? You get more than one. That's a real problem. How do you differentiate between these 5 values? So the way that this works is in assembly or in ASM scripts, ASM being sort of a shorthand for assembly. In ASM scripts, let's check our time. In ASM scripts, AOBscan will return the first value. So it will return this. And that's it. You don't get the second, the third, the fourth. You get nothing else. You get the first value, and if that's not the value you are looking for, then you are SOL and you can pretty much go spit. With Lua and some of the other sort of plugins or whatnot that Cheat Engine provides, then you get all the values and you have a much more easy way of manipulating them. But when it comes to assembly, if you're strictly limiting yourself to assembly script, such as we are in this tutorial or this series, then you are up shit's creek. And the value that we want, as you can see, 1857F121 is actually the last value. Now, how the hell can we dig this out from an AOBscan? It's pretty easy. Well, it's not pretty easy, but it should be easy-ish. The way that you do it is you extend the array of bytes that you are looking for relative to the instructions that come after it. So we have 89, 86, E0, and then 3 zeros, which is exactly what this instruction is when it comes to bytes. So let's add one. What is the first byte of the first instruction that comes after this? It is 8B. So let's just add 8B. Do another scan. See what happens. We only get one result. And as it turns out, we get a result that has an address that is exactly what we want. Now, isn't that a damn thing of beauty? As a matter of fact, it is. So how do we use this to our advantage? Now we can start screwing around with the AOBscan and doing some crazy things. So let's do that. We're going to bring up the script. Excuse me. Before we start writing, we're going to close the script. Before we start writing how we're going to actually use AOBscan, let's just one more time go over what AOBscan is. What AOBscan is doing, or array of bytes scan is doing, is it is going through every location or all, whatever it deems to be valid memory locations. It is searching the byte array or the byte string, if you prefer. It is searching the bytes. It's a somewhat simpler or simplification of the issue. It is searching the bytes that represents each instruction. And if the byte array or the byte string or the bytes that you are searching for with Cheat Engine matches that instruction, then it returns a hit. And if it does not match, then it does not return a hit. Now, it's weird because in assembly script, when you do an AOBscan, or let's not even get into that, what is an AOBscan? An AOBscan is sort of an automated way of telling Cheat Engine, I want you to go out into the memory of the process that I'm attached to, and I want you to search for this huge array, or for whatever array of bytes that I'm giving you. And it will go out and it will do that. But it takes a second. So that is why when you download a table and there are, there's a large script attached to it, when you click that script and you try to enable it, the Cheat Engine will hang. Why does it hang? Because it's out there doing AOB scans looking for bytes, or byte patterns, if you will, that in the whole memory space of the process. And in a large game or something like that, it's going to be 2 gigs, so it's going to take a little bit, or it's going to take a couple seconds, as the case may be. So again, array of bytes, or AOBscan, what it's doing is it's comparing each instruction with the array of bytes that you give it. The array of bytes for each instruction in the memory viewer is given over here in sort of the middle column, or the second column if you prefer. And if it does not match, then there's no hit and you get nothing from the script. If it hits, then you get the first hit in the script. And that's it. The way that this helps us is because the way that we can sort of make ourselves pointer agnostic with this sort of AOBscan functionality is that we don't ever have to care what points to what. I don't care what the pointer is to available karma. This during character creation, that's a sucker's bet. I could care less. The only thing I care about is what the byte pattern is, or the byte array if you want to be really pedantic about it. The only thing I care about is what the byte pattern is of the assembly instruction that modifies this value during character creation. Once you have that, which is really easy to find as we showed with show what writes to this address, once you have that byte pattern, then you can sort of go up here and go to new scan and array of byte, and you can sort of plug in whatever sort of byte array or whatever that you want, and you can just sort of new scan until you get it down to just one value. And once you get it down to one value, you can plug that into your AOBscan in an automated way in your script. And that is exactly what we're going to do in the next video. But on a conceptual basis, you can, or we can see, or sort of start to see, that you don't need to actually know what the pointer is. You just have to know what the byte pattern, or bit pattern if you want to be even more pedantic about it, is for a specific instruction. Now this gets more complicated when you get into scenarios where you have more than one instruction that's modifying a similar value. So we will run into difficulties here, just using our like, oh well, we found the byte array and we're awesome, and we're done deal, close the book. No, the difficulty is that with the game, or with this particular game, there's two methods, one for increase, one for decrease on character creation screen, and then there's one for increase, one for decrease when it comes to like player values and stuff like that, or player karma. So we can sort of mash them together and find some common ground and use that to our advantage. But when you get into multiple functions here and you're searching for array of or AOBs, what you find is that it becomes very difficult to find a specific assembly instruction based on the array of bytes that represents that assembly instruction. Now, I'm pretty sure we can work around that in this series, but it is something to certainly consider and think about, that it is when you have very similar instructions modifying very similar values, it is very difficult to sometimes differentiate between the two. And that's what we will say, and we will go from here in the next video. We are really getting into it here. Some pretty good code injection, some pretty, starting to talk about shared data. I like where we are right now. We may have left out a lot of groundwork, but we can certainly do some backfill if necessary. But I like where we are.